The final frontier is no longer just a destination for explorers and flags. In April 2026, the vacuum of space has officially become the most important industrial site in human history. For decades, we viewed the weightlessness of orbit as a hurdle to overcome, but today we understand that microgravity is a unique manufacturing tool that cannot be replicated on the surface of our planet. We are entering the era of the orbital factory, where the laws of physics are rewritten to build the future of medicine and materials science. The primary reason for this shift is a fundamental force we deal with every second: gravity. On Earth, gravity causes convection and sedimentation, which are the enemies of precision manufacturing. When you try to grow a protein crystal or a human organ on the ground, the heavier elements sink and the lighter ones rise, creating flaws and structural collapses. In the microgravity environment of a commercial space station like Starlab, these forces disappear. This allows for a level of molecular perfection that is physically impossible under the constant pull of Earth's 1-gram environment. One of the most life-changing applications of this technology is 3D bioprinting. On Earth, trying to print complex human tissues like heart valves or lung scaffolds is like trying to build a skyscraper made of jelly. The structure simply sags and loses its shape before it can solidify. In orbit, these delicate biological structures can be printed in 3 dimensions without any support systems, allowing cells to grow into their natural functional shapes. By the end of 2026, we are seeing the first successful transplant-ready tissues being brought back from orbit, providing a glimmer of hope for the millions waiting on organ donor lists. Beyond biology, the manufacturing of specialized materials is seeing a massive boom. Zebra and optical fibers, which are capable of transmitting data with significantly less loss than standard glass, can only be produced with high purity in space. When pulled on Earth, tiny crystals form within the glass due to gravity ruining its efficiency. In space, these fibers are pulled into perfect, flawless strands that could revolutionize global internet speeds and long-distance communication. We are also seeing the production of ultra-thin solar cells and semiconductors that are more efficient than anything we can produce in a terrestrial clean room. The logistics of this new industry have been enabled by the radical drop in launch costs and the arrival of autonomous orbital platforms. We are no longer relying on a few government-run space stations. Private companies are now launching factory modules that remain in orbit for months at a time, where robotic systems handle the delicate work of mixing chemicals and printing tissues. Once a production run is complete, a re-entry capsule detaches and brings the high-value cargo back to Earth, landing in the deserts of Australia or the plains of the United States. As we look toward the end of this decade, the Made in Space label will become a mark of absolute quality. The medicine that cures your disease or the chip in your next computer may very well have been forged in the silence of the vacuum. We are shifting from an era where we went to space to see the stars to an era where we go to space to build a better life for everyone back on the ground. Hi everyone, Mark here. If you are fascinated by the engineering of the future, subscribe and follow for more science, natural and cosmic content. Join our community, link in the description.